Hi, and welcome back to Particleworks Power-Ups. My name is Jack Kelton. I am a project engineer here at EngineSoft UK, and I've been working with Particleworks for coming up on 5 years now. Today's request comes from a chemical production company. They told us we would like a method to calculate and display additional metrics within Particleworks. We would like to be able to measure how fast particles are moving about an axis within a mixer. Please create a macro to do this for us. Previously, we would have had to export the data, process it externally, and then display it in another tool, such as PowerView. Nowadays, we can use the Python API to calculate a new field, feed that new field back into the prof files, and then display it in the GUI the same way you can with any of the other standard metrics. First, I import the necessary modules. Here, those are System, OS, and Pandas. Then, I do the usual initiation, i.e. setting up the bin folder, importing pwpy, and also setting up the session, scene, and project. Then activate the scene and define a few variables that I'm going to need. The results directory of the simulation, also the number of frames to loop through. And then begin the loop for each frame. In each loop, I need to define the file path for the prof file so I can later overwrite it, load up each frame, create the custom field, and then save said frame. I create a variable for the particle data that I'm interested in this case, the MPS particles, and then I also create a variable for the custom field that I'm going to create. So in this case, I'm doing the circumferential velocity around the x-axis. Here, I'm using the add scalar function, as circumferential velocity is a single value, but you can also add in a 1x3 vector and a 3x3 matrix. To make the data easier to work with, I prefer to load the information into a pandas data frame. To do this easily, I first transfer the relevant information into a dictionary. Here, I just need the XYZ position and velocity of each particle. I then load this dictionary into a data frame and apply the desired function to create a new field. In order to calculate the circumferential velocity, I need functions for creating a unit vector and also for calculating the dot product of two vectors. To save time, I'm copying these from a previous script. To actually calculate the circumferential velocity, I need the tangential vector from that particle's position as a unit vector. That is made easy here as the centre of rotation is the x-axis, and I also need the velocity vector of that particle, excluding the x component. From there, the velocity in the circumferential direction is simply the dot product of the two previously mentioned vectors. After that, I add in an except to the try loop so that the script won't fall over itself in the case that there are no particles in a frame, or some other vague issue. I then create a list of the new field values and then assign them to that previously defined Particleworks array. I do this by looping through each element in one of the lists and then assigning that element as the equivalent one in the list of the new field. Finally, I then go back and add in the missing return for my unit vector function. Here, we have an example simulation of a cylinder rotating in a vessel full of a viscous fluid. We run the script by dragging it onto the scene from a File Explorer window. After this is finished, you can refresh the color map and see that a new option has been added. Selecting this and setting appropriate minimum and maximum values shows what you would expect to see. We have a higher velocity at the tip of the moving cylinder and a reducing velocity profile away from the moving cylinder. If you're looking for a more efficient way to use Particleworks, or have a specific issue that you would like support with, then our contact details are on screen now. For more information about our full API online training course, please visit the contact page for details. See you next time.